Do you want me to send you it's like a way at the beginning?
Just right here's good.
Here's
You've
good.
got your.
Yeah. I've got my laptop. It's ready to go when you want to switch over. Yeah. I'm gonna go. So there's that.
Let's do one last.
Yeah, that's all good. I think it'll be fine.
I'm right. It'll be fine until everybody starts asking questions.
Yeah, well, I've been told. Well, the only thing I suppose I have to mention about is how I'm supposed to pick the best question about the t-shirts. So, yeah.
But that one for those political decision.
Yeah. So, well, sorry, that question can't be the best one because we don't have your size of t-shirt or whatever.
I think you might be able to.
You've been to some of those before? Where it used to be online.
Oh, okay.
That was the question.
Oh, okay.
Never lived through it.
Yeah.
There's white wine in the fridge.
It's become
red wine out.
about every other one for the last few years, couple of years.
Yeah. Okay, welcome everybody to the SecOps London Gathering, May events. I'm glad you can all make it. It's a really good turnout. We've got to say thank you to Vericode for an excellent spread of food and giving us the space for this evening. And hopefully we'll be here a few more times this year as well. So Michael, our founder, is at the back there. He's the guy who actually provided the space for us. So thanks, Michael.
Thank you.
Yes.
And personally, I just want to say thank you to Frankie and Jess for doing all the hard work over this month. I've been very busy, I've been away a lot, and they've both been putting a lot of effort into this particular meetup. So thank you both of you. I really appreciate what you've done for this month. Okay, so that's our meetup.
So spoiler alert.
Spoiler alert. So this is us, although it's not quite us anymore. Steve's not around at the moment. He'll be back hopefully next month. But you got me and Jess, and we've also got Frankie. Who hasn't got an image up there yet. We're going to work on that.
One next time.
Get an image up there. If you want to get in touch with us personally, these are our Twitter handles. We're on Twitter and also on LinkedIn. So if you want to get in touch with us privately, then you can do so. I think.
Let us know if you have a blue sky invite anyone out there.
If anyone's got any contracts for me, I'm on the lookout. So. If you want to keep in touch with all of us as a group, best way to do that is through the website, the dsolg.com, where you'll find all the information that's on here. Email us at team@dsolg.com. If you want to be a speaker, if you've just got a comment or you've got some suggestions, some ideas, just send us an email. That is the best way. All of us can see the email, so you can get in touch with us that way. Obviously, the meetup page through the SecOps London Gathering meetup page, that's how you probably found us. That's how you probably RSVP'd for tonight. We're also on LinkedIn. We often stream these live through LinkedIn, so if you can't ever make it one evening, then do check out our LinkedIn page and we'll stream it. And likewise on YouTube, where we have some previous events. Are there. We also have a podcast, which I think we're going to be recording one with Charlie after this. So do listen out to our DSO podcast. This is the logo, so look out for that. And we've got some great talks on there from the back catalogue as well, so do check it out. Do subscribe. And there you go, DSO Info Podcast. It is available on all platforms, all good platforms, such as Spotify and Apple. Do check it out. want to give a shout out?
Yeah, we've got a bit of a special shout out this month. So we usually give like a shout out to some of the other kind of community groups that we work with quite frequently, that we support, that we think are doing really interesting and cool things. But we wanted to give a special nod over to the BCS. So I think Roy.
So just a quick word, if I
Yeah,
can.
yeah. Please.
So blatant plug. Yeah. So we have a BCS DevSecOps group. If you're not aware of us, it's very easy. You look up BCS DevSecOps group on Google, and you will find us. And we have an event next Thursday on Elastic, and we have another one in June. I can't tell you what that's on yet, but it's another exciting topic. And if you're interested to sort of see what we're doing, have a look at the website. So, and that's in London and online next Thursday if you want to come and join us. Thank you.
We'll send out a link to everyone on
Yeah.
the meetup page. So if you didn't keep things like clickable, right? So yeah, if you RSVP to tonight, then you should get a link.
We've also got Matt here from the DevOps. Matt, have you
Oh
got
my
any
gosh!
events? Have you got any events going?
Hi, good to meet you offline. That's really cool.
Have you got any events?
Have you got any
coming up?
events?
Yes, we are running in June the 15th. I can't tell you who it's with, but it's with a major cloud provider, which isn't Microsoft and isn't Google. Thank you. So yeah, over Principal Place, Amazon, 15th of June. I need to send you our new logo.
Yes, please. Yes, please do.
Brilliant. And we would not be here without our sponsors. So we wanted to give a quick shout out to the other sponsors that aren't the brilliant event sponsor. Thanks again, Very Code. So Sysdig, Sysdig, everyone knows about Sysdig. They can help you prioritize vulnerabilities, detect and respond. You can visit their website for more details. And they occasionally do giveaways here as well. They once gave away like some headphones and some t-shirts. So they are a sponsor that likes to give back. So we give them back. We give back to them by shouting them out. And it's the same with Prisma Cloud by Palo Alto Networks. Usually Steve is the person who does this because he works for Prisma. So he usually does the party line really well. So I'm going to not do the crowd tonight, Steve. Sorry, you should have been here. And then our newest sponsor, so Apiro. So Apiro are doing some pretty awesome things. I think we had an event with them back in, was it January or February? They're doing some really interesting stuff around like vulnerability detection. So yeah, release of confidence. Yeah.
If it wasn't for those sponsors, we couldn't have carried on with this meetup there. So we're very appreciative of all those sponsors.
And you can also become a speaker. So we've spoken to a couple of people here tonight who've drafted some really exciting talks. I've got a couple that I think are going to be really good later on this year. So please submit your talks and we'll get them scheduled in because we've got a good 2023.
And if you go onto our meetup page as well, there is a form there so you can easily just fill out all of the details and we'll get back to you.
And if you don't feel brave enough to do a full talk, and you just want to do sort of talk for 10 minutes, you've got an idea, you want to run it through, you've got you want to do a CFP for a big order, big event, but you just want to get some ideas out there, see how you get some feedback. We're more than happy to give you 10, 15 minutes to do a lightning talk. So don't feel you have to fill an hour, hour and a half, or whatever. Yeah.
And finally, save the date for our next event, which is June 21st, and we'll be having two talks actually, from Robin Musa at Sysdig. More details to follow. We'll be sending that out after today's event. And finally, it's over to Charlie. We have Charlie joining us today. Joins us from Styra, and he is going to be talking about all things OPA.
Okay, thank you. Thanks very much.
Charlie.
Thanks, Charlie.
No.
I mean, I don't know, can people at the back hear me? This is how I would speak. No, I don't think I need it. I think I can
Project.
Yeah.
Although it might be good for people. Oh, is that connected to?
No.
No, okay. Hopefully, it's just learned enough with my normal voice. Okay. So yeah. Hello, everybody. Great to be here and to have an opportunity to talk about two of my favorite topics again. So yeah, the talk today is about 2 open source projects which I'm interested or involved with, and how you can use the 2 projects together. SPIFFE and OPA, the 2 projects. One of these is more in the authentication space, and the other one is more around doing authorization. And if you're not familiar with what those projects look like or what those challenges are with authorization and authentication, then we'll talk more about that as we go through. So first, a little bit about me. I'm Charlie. I work on the developer relations team at Styra. I started at Styra at the end of last year. However, I've been involved with the Open Policy Region, or OPA, project for some time. I'm interested in all things authentication and authorization. Obviously, Styra and OPA is in the world of authorization and policy checking, or generic policy checking. That's where I spend a lot of my time. But previously, I was working at a company called JetStack. Some of you have maybe run into JetStack people here in London or elsewhere. That's where I was working before, and that, I suppose, is where I came into contact with SPIFFE. JetStack has become quite involved with sort of X509 and certificates and things, maybe in a sort of cloud native take on that topic, but that was where I came up against SPIFFE for the first time. So I suppose the role of Styra for me still feels relatively new, and this talk is about bringing those 2 topics together. If you want to get in touch with me, there's various ways you can do it, but they'll be at the end as well. So, but it's generally Charlie Egan3 everywhere. So, just to set the scene and to make sure that we have some shared vernacular, I suppose, I think it would be good to have a think about what I mean, or what we all mean when we talk about a workload. So, when I say that word, people have probably got some preconceptions around what that means. If you're in a Kubernetes environment, it might be a pod or a container. If you're working with VMs, it might be one of them, or it might be an instance of a serverless function of some kind. And I think I would like to include all of those different definitions under my definition for a workload, and think of a workload as a running instance of some application, whether that's a long-running web server or a instance of a batch job which is just running to complete a particular unit of work. That's what I'm thinking about when I'm talking about a workload, and I'll talk about workloads generically throughout the session. So when workloads are interacting with each other, we're living in a world now where this is something that happens, and one workload needs to call another workload. Maybe it's an image service that's being called by a proxy or front end. There needs to be some way of these workloads trusting each other. So we have systems for establishing trust that we use all the time elsewhere. So when you visit a web page, you see the certificate, or you might not, but your browser will warn you if it's not configured correctly. And workloads need a similar system to establish trust between each other. And when I say workload identity, you might be thinking of lots of different ways that you might implement that. Maybe it's an AWS key and key secret. It might be a Google service account. It might be a certificate. It might be a username and password, or an API token of some kind. But in terms of what they are doing, I think if we generalize a little bit, they're about establishing trust and are allowing a workload to establish that it is who it says it is, and the service which is being called, or the workload which has been interacted with, can know to trust the caller as well. So I gave some examples there: username and password, AWS credentials, whatever. I suppose the point that one of the ideas, or that I'm trying to get across in this session, is that not all systems of workload identity were created equal, and some are better than others. And I suppose, to go back and compare with what we use as humans, or as people who are interacting with computer systems, some ways that we log in are better than others. If you share your password with your family or your co-workers, we understand that isn't as good as maybe using something like a passkey, which is specific to your device, or a YubiKey, or some kind of hardware authenticator, that we can understand that in different environments, or under different requirements, there are there's a gradation of how good these are. And while I was working at JetStack, I wrote a blog post about, well, this is the title of the blog post. It's about SPIFFE and trust domains and fits in with what we were working on at JetStack at the time. But as part of this work, I spent some time trying to write down what I thought a good workload identity was and what the requirements that we might, or the features of a workload identity system that we would want to use what they might be or what they might look like. So the first factor that I think a good workload identity should have is that it can be short-lived and automatically rotated. I suppose those two factors go hand in hand in that if it's going to be a short-lived identity or means of proving an identity, it needs to be automatically rotated because we can't automatically rotate many sets of identities manually, or we can't do so efficiently or cost effectively anyway. And in a modern environment, we might be talking about millions of identities rather than 10. So again, that's a feature that we would like our system of workload identity to have. Another feature is that good workload identities can't be or are not subject to man-in-the-middle attacks. So a man-in-the-middle attack is where the communication channel between two workloads interacting with each other, or two actors interacting with each other, is compromised in some way, and through that channel being compromised, a malicious actor that has put themselves in between two different workloads is able to impersonate the identity of one of the parties. And a good system for workload identity wouldn't be subject to that particular type of attack. It's a well understood attack vector that would be nice to make sure we're not subject to. The other factor that we would like our workload identities to have is that we can carefully control how they're bounded or where they're trusted. So, for example, you might be starting to, based on some of the requirements I've already said, and in fact, the diagram that I used, you might be starting to think about certain technologies that we might use to implement a workload identity system, and you might be thinking about certificates at this point. But it's common for us to interact with certificates in a way where they are publicly trusted or interact with publicly trusted certificates. And the problem with publicly trusted certificates is that they are just that, they are publicly trusted. And for some definition of unbounded, their trust is unbounded, where most devices owned by most people, most places in the world will trust a certificate. And that includes servers or laptops or mobile phones or whatever. And a good workload identity or a good system for managing workload identities, we shouldn't have our workload identities trusted everywhere. We should be able to say this set of identities are related to this set of workloads in this particular domain that we want to define. And that should be, if we want to make those workload identities valid somewhere else, that should be up to us, and it's a conscious decision that we make to expand the bounds of trust for a particular identity. This one is kind of, I suppose, the most maybe contentious, or represents, I suppose, my own opinion the most. But I think it's an important one, which is that when we're using workload identities, and workload identities are being parsed and sort of acknowledged within our system, it's important that when a workload is doing some work in order to respond to a caller or another workload which is interacting with, I personally think it's important that the workload which is being invoked knows who is calling it. So if the client is talking to the server, and it's a particular client talking to a particular server, it works both ways. The server knows who the client is, and the client knows who the server is. And that's, I think, an important feature that I will dig into a little bit more. But I think just to sort of motivate this example, like, I think it's very easy to in particularly in the days of service mesh and so on, it's easy to think about, or it's easy to be tricked, I feel, again, my opinion, into thinking that you don't need to worry about having your applications be aware of their identities or aware of the identities of their columns. And I think that's problematic for a few reasons. It's often important that you want to get an entire trace through a distributed application. And if you drop identities along the way at different proxies or different jumping off points, you can lose some of that context. But I think the other thing that's important is that in some applications you don't want to enforce policy, but this talk is about policy as well. And there are good use cases for enforcing policy based on identity within a workload. And unless you are very good at configuring your service mesh, some of those policies are challenging to implement outside of an application and actually do need to be owned within an application. And there may only be one or a small number of services that will have that requirement, but you don't want to have a workload identity system which makes it impossible for a workload to make policy based on identity. So that's the final factor that I got to talk about. So aware the text might be a little bit small in particular for anybody who's watching the stream, but the idea here is that I've got some different workload identity systems and a comparison of them against the different factors that I've just outlined. So shared secrets, or what I refer to as when I say shared secrets, is a password that I know and the server knows, or the server knows some version of the password. Just imagine some kind of simple API token or something, some kind of system like that. Is it short-lived? Well, it's only as short-lived as you make it. Generally speaking, it's not short-lived. If people wait longer than we would like for them to renew such tokens or sets of credentials, they're often shared, so that makes it harder to renew them or to rotate them quickly. So they fail on the short-lived criteria. They're also often not easy to automatically rotate. They are replayable. So if such a credential is logged to some logs which get leaked or are sniffed by some actor in between two services, they're subject to being replayed, and impersonation is the inevitable outcome there. Their scope is unbounded. So if you share your password with anybody, anywhere, provided there's network connectivity, that credential representing an identity would work. The final factor, does it prove who you are? Well, kind of yes, like the server or something maybe needs to process the API token which it's being presented with, but so it does know who it's interacting with, but it fails on all other heads. So something that another system or another workload identity system I'd like to compare things against is the idea of using publicly trusted certs to your workloads. And this is something that we used to see when I was working at JetStack, and people were using Cert Manager project. Who's using Cert Manager? Anybody use Cert Manager here? Got 1, 2 Cert Manager users. That's great. And it's interesting because Cert Manager, so Cert Manager grew out of the kube-lego project, which is Kubernetes, let's encrypt Go, bring them together, and you get kube-lego. Fun fact is it was actually the initial employees' interview project. But that's kube-lego was eventually deprecated, and Cert Manager came along, but it was still kind of often known as the let's encrypt operator of Kubernetes, and that was the most common use case. And it was easy enough to use, and people used it, and they used often. People would come to them, we're using publicly trusted certs, and they had some interesting system of getting publicly trusted certificates to their workloads in Kubernetes, for example. And so this column is for those people and to try and explain to them why that's not such a good idea. Are they short-lived? No. So when you're getting publicly trusted certs, generally speaking, unless you're using a particular type of public CA, they are not short-lived. They're usually lasting a number of months. We would ideally have short-lived credentials, or we're usually in a position to be able to issue short-lived credentials than that. So they fail on that. They are automatically rotated. The reason we can't have sometimes challenging to get short-lived ones is that there would be tremendous load on the public CA to issue the known volume of certificates that would be needed to run potentially for an identity system for millions of containers or whatever. And so that's why they tend to offer slightly, well, one of the reasons they tend to offer slightly longer certs. But yeah, so it fails on that front. They're not replayable, which is great. The private key material doesn't travel over the wire, so they are not subject to the same replay attack that we talked about earlier, so that they're good on that front. The scope isn't bounded again, it's publicly trusted, so it fails on that front. And it is known by the service that it's calling it, it's opening up as part of a mutual TLS connection. So it does okay. It's a bit of an improvement. It's a big improvement, actually, but it's still not what we would necessarily want. The final system is a system that many people are familiar with, is Service Mesh. Is anybody using Service Mesh here? A few users of Service Mesh. So I don't know exactly why you deploy Service Mesh, but a common reason that people do is to get a system of establishing mutual TLS between workloads. There are other features as well, but that's a common use case. And I think service meshes are actually really quite good at achieving what we are looking for, what we're driving at. They rotate credentials for us, representing workload identities, giving us short-lived workload identities as we wanted. They generally are service meshes that I'm familiar with are using S509 certificates to do so, and so they're not replayable, which is great. The scope is carefully bounded depending on a given service mesh or a set of meshes that's federated in some careful way, which is great as well. The only sort of pain point or thing that I find frustrating about the service mesh mentality is kind of trying to offload certain responsibilities to the mesh away from the application. And one of those responsibilities is around identity. And it's not part of the default configuration or the default way that people use service mesh to forward the identity to the wrapped workload, for lack of a better word. And then that workload is then unable to do some of the things that I think people should consider doing for security in depth, good security posture around policy and identity-based policy, but also tracing of identities and callers as down a series of chained service calls. So service meshes are pretty good, but for the purpose of this talk, I'm going to be talking about a different way of doing it, which is to use SPIFFE flavored MTLS. And there's it's worth highlighting that service meshes, some of them actually use SPIFFE IDs and so on. But the idea here is that rather than service mesh and service mesh proxies terminating your MTLS connections between workloads, is that workloads themselves are terminating MTLS connections and are therefore aware of the caller identity, which is represented or presented in the client certificate. So yeah, introducing SPIFFE. This is the first of the two different projects that I wanted to talk about. SPIFFE is the secure production identity framework for everybody or everyone. And I think, well, it's short-lived. It's based on, there's a flavor of it, which is based on S509 certs. It's not replayable because it's S509 certs again. Yeah, so short-lived, not replayable. The scope can be carefully bounded, and the SPIFFE spec has terminology to describe domains of trust, which I think is quite the design. Something that I was working on a little bit while I was at JetStack, but didn't get to finish it off. And again, if you're terminating, so there's a SPIFFE Go project, for example, which helps you write applications which are ready to terminate and deal with SPIFFE MTLS connections. And if you were using that, then you know who's calling you and who you're calling. So how it works is that it's a way of setting up an MTLS connection between two workloads. And it looks at the certificates that are involved in that. Channel of communication look a bit like this. It's hard to fit an entire certificate on a slide, but the important bit really is this extension, the subject alternative name. There's a URI extension where you can put in that a SPIFFE ID. And a SPIFFE ID is a URI representation of a workload's identity. So The way that it's set up is the protocol is SPIFFE. The domain represents a trust domain. So if you had a common, people can use trust domains however they choose to, but common way you might have it is the production and non-production. Workloads are in 2 different trust domains, so this might be prod.yourcompany.com. And then the path segment of the URI basically identifies, or should uniquely identify, a logical group or a logical workload. And again, the URI is use that however you like. A little bit of hand waving. There are lots of different ways you can get SPIFFE IDs to workloads. These are some of the ways that you can do it with either service mesh products or things like service mesh products, or the Cert Manager CSI driver SPIFFE can do it as well. There's Spire, which is the kind of reference or supported implementation of and has support for all sorts of different ways you can get SPIFFE IDs to all sorts of different devices and in different environments. Whoops, that's not the topic for this talk. This talk is really imagining if you did live in a world where you had SPIFFE IDs, what could you do with it? So this is the world that you find yourself in. You find yourself in a world where you've got workloads and they all have SPIFFE IDs, and you want to enforce policy over how they're communicating with each other. And you might be thinking about how could I do such a task like that? Well, there is another project. It's called OPA. It's the Open Policy Agent. It's what I spend a lot of my time working on, and it's a general purpose policy engine, which you can use in exactly this context. So just as a little whirlwind tour of OPA, like just a quick shot, is anybody using OPA here, or 1 OPA user, 2 OPA users? Okay, so that's great. I'll hopefully this won't be too boring for those of you who are already using it. But the OPA really is, like I say, it's a general purpose policy engine, and it's centered around this domain-specific policy language called Rego. This is a short example, Rego policy at the top here. The idea is that you evaluate a policy with some context, some input data, maybe some data in addition, which is available from other data sources. You evaluate the policy code, and it gives you a response. So in this example, we evaluate a policy that checks whether a user's role is admin, and with data that looks like this. You would call it by posting the data to the Open Policy Agent instance which you have running, and it would give you a response back as to whether or not it was allowed. So if Alice didn't have the role admin, had some other role, then the request in this instance would be denied. And yeah, like I wanted to extend this talk a little bit. Like that policy is pretty. It's trivial to implement in almost any language that you've ever worked with, likely. And I think I just wanted to sort of maybe give a slightly more, as far as the language is concerned, slightly more motivating example of a policy that you could write. So imagine that you have some data that looks a bit like this. You have an organization chart, and for each business unit within the organization, so boss is a business unit, human resources, developers, these are business units. You explain who they are managed by and what access they have, access to particular data sets or environments, for example. If you have that data, you can set up a graph of that data in your policy code. The way you would do this is by finding some business unit in a pair of key and value in the organization chart, which was on the previous slide, and you can find the edges that are for that business unit based on looking for neighbors in the organization chart and looking at the managed by field. And so if you evaluated this particular piece of policy, the data that would be returned is over on the right-hand side. So we can see that in this case, we have edges from the boss to developers and human resources, developers to interns, and so on. Then we can use another piece of policy to aggregate business units, or look for each business unit, and using a built-in feature of the language, graph.reachable, we can search through the graph and find for a given business unit which other business units they can reach, and then we can aggregate the access for all of the reachable business units. And so we get a list of permissions. So the boss has access to everything. Developers have access to the two engineering environments. Human resources have access to salaries, and interns only have access to dev. And so, aware that maybe looks slightly overwhelming, and if anybody wants to dig into the policy later, we can, but I wanted to just give an example of a policy that wouldn't necessarily be trivial to implement in another language. There are many other benefits to using OPA versus implementing policy in your applications. They're generally at a higher level around standardizing how policy is implemented or enforced across the business or across a whole suite of applications. But that's kind of a topic for another day. Sorry, just how you would use this policy looks a little bit like this, where you would say user is requesting a particular thing. You look in the org chart permissions, and some requests would be allowed and some would be denied based on whether or not they existed in this structure. And so you can, at the end, have quite a simple policy. So we've talked about SPIFFE, we've talked about why SPIFFE is good, or why I think it's good, and I've hopefully given you a little bit of a sense of how OPA works with this language and how you invoke it by calling its API. We've got these two projects, what can we do? So I've got a demo scenario that I want to talk through, which is around the booking of trains or booking of train seats. So some of you have probably sat on a train that looks a little bit like this, and you have looked at a screen that looks a little bit like this. And I've created a scenario which is with that in mind. So the idea, I've never driven a train, but the idea is that the train driver is sitting in front of the train and they're about to start the train service. They're at a particular station when they do so, and they need to update the screens on the train. So the screens are blank, and they often are blank when you get on the train. So presumably somebody somewhere is making sure that the screen has that information on it. So the idea here is that, yes, that there's the train driver is sitting with the train computer or something at the front of the train. They're communicating with over a local connection to something at the local station, and the local station is connected with a very long cable to the train company headquarters. So we've got a user device, and we've got two services in two different locations, and we're going to see what that looks like and how we can identify different actors within that system and how we can enforce policy around it as well. So in a slightly more boring presentation of this scenario, it looks a little bit like this. The train driver has a web client. They're going to be talking to a reservation service, which is running for some reason at the local station on a server somewhere at the local station. This reservation service is going to talk to its local open policy agent instance, which if the request passes the policy, it's going to make the request all the way back to the HQ in order to get the list of bookings, which is going to do some further validation with a different OPA at the company headquarters before sending the data all the way back down to the client here. I've also got something which is a kind of demo configuration tool which I'm going to use to manage the policy, which is running different points as I go through the demo. So requests along the way look a little bit like this. The web client makes a request for a reservations endpoint, specifies the train service and the driver's ID. Consultation with OPA looks a little bit like this, where it sends the train and driver to OPA for policy evaluation. Then the reservation service makes a request to the booking service, the train service ID and the driver ID included in the header this time. And then the booking service is going to call OPA again to see whether this request is allowed. And it's also going to make an additional call to the OPA instance to make some policy based on how it should format the data. So not just on whether a request is allowed, but exactly what the request should look like. So yes, that's what the demo setup looks like. And now I'm going to try and type at this slightly different angle. So this is about as good a UI as you're going to get this evening. But the idea is that this is what the train driver sees. So this is meant to be this is intended to be the train driver view, and they click. Well, the idea is that they fill out their train service and their driver ID, and they will get the reservations for that train that they're about to run. So if I click fetch at the moment, you'll see that I get this error message back saying that the station OPA only accepts authenticated clients. So what's happened is the request has got to the reservation service, and then the reservation service has tried to call this OPA instance, and OPA is saying, go away, you're not identifying, or I'm not able to understand exactly who you are. So the first policy we're going to set, or make sure it's correct, is the policy which is what's called the authorizer policy for the OPA instance. So a little bit of context that I should probably have given earlier is that as you're evaluating policy, one particular policy might expose some confidential information versus another policy, or you might want to control who is able to call which particular policies. Whether or not you want to do multi-tenant OPA is another topic, but there is a feature of OPA which allows you to validate callers when you're interacting with it. And that's the feature which we're running up against now. And crucially for this talk, I've made it such that that feature supports the use of SPIFFE ID. So at the moment, you define the policy in the system authorization package. At the moment, allow will always be false, and the message that's returned is as we saw here. So I have some policy that I had prepared earlier, which is great because if I try to type this out on this angle, it would be very difficult. So I'm going to paste this in and update it, and then I will talk about it. So previously we just had this part, which was denying anything, but now we've got this additional definition for allow, which will be true if we are able to extract from the client certificate URI details something that looks like a SPIFFE ID. You could do further validations, and ideally would do further validations on the SPIFFE ID, but in this case, we're just checking whether there's some information in a URI SAN. So now if I refresh my request again, I can see that the headquarters OPA is only accepting authenticated clients. So now this reservation service has consulted with this OPA instance, and it's forwarded the request to the booking service, and it's now talking to this OPA instance over here. So that doesn't really seem quite right though, or what we would really want, because remember that my train driver hasn't actually even filled out this form. So I think it would be nice if this OPA was able to enforce some policy that said, hey, this request at this point needs to be non-empty. So I'm going to put in some details for a train service just now. The train service and train driver ID, they're not very imaginative, but that's what they look like. Oh, whoops, sorry. I think I actually should have done the policy first. So I'm going to go and update the policy which is running for this particular endpoint in the local station OPA, which says that both these fields must be set. So I'm going to go and update this just now. And then, so if I just don't set one of these, I'll just unset again, sorry. It says that the driver must not be empty and the train must be empty either. So I'm going to put these in again, and then the request should be allowed through. So just as a clarification, we've enforced some policy here. The reservation service is consulting this OPA instance and is validating that the fields are set. So they should be set like this. And now we're back to the same message we had before, where the request has been approved by this OPA instance here as being non-empty, and based on the data that's available at the reservation service, that's all it knows, and all that it can really validate is the input, and so it's decided that it's going to send it off to the booking service, but the booking service is having the same problem where it can't talk to OPA. So we need to go and update the OPA authorizer in the company headquarters. And so this the policy that I'm using to authorize callers from within the company headquarters is a little bit more involved. So I'll just copy and paste this in here and talk about this one as well. So again, we're denying by default. This is the message that we were seeing before, but this time we are controlling which policies. So or which policy, so you evaluate different policies by calling a different endpoint on the API, are available to which service. So here we're saying that list allow is available to the booking service in the HQ cluster. We're doing a similar, well, we're also checking that we have a valid SPIFFE ID, but we're also saying we're taking the SPIFFE ID from the caller and looking up in the ACL. So this is a SPIFFE ID. So given SPIFFE ID, you can do a particular set of paths. And that's what this policy is doing. So we say if we're only allowing true if the input path, which is part of the object which is given to the authorizer policy within OPA, if that is contained within the ACL when we look up the given SPIFFE ID, then it's allowed through. So if I refresh this now, I'm actually going to get an error message which says that this particular path can't be called, and that's because there's a not so much of a mistaken state in the policy that's written. So I've said that the service is allowed to talk to list allow, but my application is actually trying to talk to deny. So there's a mistake in this policy, so we can go and update it. So I'm going to change this endpoint here to allow it to call the deny policy. And so now if I refresh, that one will work. However, our application, remember, is doing two things. It's authorizing the booking service is authorizing the request, but it's also going to make some customizations on the data which is going to send back to the reservation service based on some policy as well. So what we're seeing not there is here is that we are trying to call this other endpoint called option. And that's the policy endpoint which defines how the application should be responding to the request. So I'm going to go back and actually I want to go. Sorry, it's this one. And then I'm going to edit this, and I'm going to allow it access to that other policy endpoint too. But that should be fine. And now, for the first time, we see a response to the. For the first time, we see a response to the driver's request. So they've made a request for train service 0001 and their driver 0001, and they're getting a certain amount of, again, the reservation data for their train back. But there are some things that we haven't fixed yet. So at the moment, they can actually request. So if they were logged in as a different driver and were sending a different driver ID, they would still get results for the train service that they requested, regardless of them being a different driver. So this train service is meant to be driven by driver 0001, but they're actually a different driver. So we're not updating that. So let's enforce the policy to make sure that is set up correctly. So let's copy this bit and update this one. So what's interesting about the booking service is that it has access to more data. So the booking service is when we call the booking service, we supply some information about the different train services and who drives them, and we do the policy evaluation in the context of that additional data. So rather than just we duplicate or we share some of the policy with the reservation service around checking that the values are on empty, but we also are able to write this other rule which says if it's true, the driver does not match the requested train service. So we can look up on the train services which were given the input train service, and if that doesn't match the driver the driver of that train service doesn't match the driver that we're given, then we can also deny that request. So if I go and fetch this again, we should see that the driver does not match the requested train service, which is exactly what we wanted to see. So put that back to what it should be. So now we've validated that the train driver is only able to make requests against or for that particular train that they're actually driving in the list of train services that we have. But I don't know if anybody else has something, or anybody else can see something about this data set that the train driver is looking at when they're about to update all of the train seats on their train with. Is there any information in this page that you might not expect or might not want them to have access to?
Oh,
Yeah.
Exactly. Okay, so one person would say it, then I could give away a t-shirt or a book or something. But me, or you just have to remember who you were, and then maybe you can. So yeah, we want to make sure that the train driver doesn't see this. So what we're going to do is we're going to write some policy which states that if the information that is being sent by this booking API, if it is from the reservation service, and I suppose initially from the train driver, we're not to provide feedback. So we can write some policy for that. Okay. So at the moment, option is just empty. There are no options, but I'm going to add a new option called ship email. And how this will work is if the station one reservation service is calling, if the caller or the booking endpoint, their email will evaluate this. Otherwise, it won't be successful. So now that I've got that policy, you remember our application is making that additional call to do some options processing on the page. The service will now behave differently based on the policy, which is based on the caller. So I'm the reservation service, I'm talking to the booking service. The booking service is changing its behavior on who the caller is. So yeah, that's it. That's my demo. I have like a few slides just to talk about. Just all of what we have seen. So the first thing we've seen is that we can use the IDs when we are aware of them in our applications to interact with instances of open policy to call specific policies. We can also use those SPIFFE IDs in policies to define how the application is behaving. Let's that again. We can use SPIFFE IDs to explicitly state which policies a given workload can evaluate within an OPA instance. That's the first thing we show, and I suppose that's the of note thing that I suppose I added to OPA in order to talk about this particular topic. We've seen how we can use a workload to consult an OPA instance in order to make an authorization decision, whether a request should be denied upfront or allowed through. And we've also seen how an application can make an additional call or some other interaction with an OPA instance in order to control its behavior. So it's a policy-based behavior decision rather than a decision that we're all quite familiar with. So, as I mentioned, I made a change that allows us to present the certificate information when in OPA to authorize the allow access to policy. There's other things I'd like to add to OPA. So the way that the OPA instance has been loading policy all the time is something called the bundle API. If you use OPA via one of the integrations, use the test, but other use cases where you would how you can policy in that is not necessarily possible to use in that particular use case. And the other thing that I think is an obvious example to add is to make some to allow you to write some regular policy which is done immediately aware of 50 concepts like custom names. So you can say SPIFFE ID, SPIFFE ID, is about SPIFFE ID, true, false. I write policy around these kinds of things. But also say like, oh, I have a SPIFFE ID, is it in a particular domain? So those would likely to be language features or something. Just some other ideas. So yeah, that's all I've got. This is kind of everything that I've made reference to. The QR code will take you to this page here, which is on my. Oh, sorry. This page. And there's also like slides and recording or whatever on there as well. Again, my details are there. I'm Charlie Egan 3 in most places. So yeah, like hopefully that was interesting, and I don't know whether anybody has any questions, but I'm happy to talk about it. Yeah, he's getting the microphone.
So can you give on the issue side, or I mean, in fact, if you want to filter some on the like just I mean, so I want to get exposed to somewhere. So body level.
The question is about where the ACL comes from.
So the policy you are applying on the service mesh level, on the I just want on the body level, like for education, have to export to them on the service.
Okay, so you want to write policy around
On the body level.
I see. Like on so like they can send the request to certain fields.
Yeah,
Like that. Yeah. So I suppose it depends on like where your like required boundary would be. Like, do that for each application, or are you going to do that as it's going through some gateway policy? Like not exactly like where you would need to.
I think there is one what it called that's maybe something, but I don't know how to work.
Yeah, I'm not familiar with that project, but I suppose you saw in the example where I redacted the email, for example. That's in a response body. So that's an application is preparing a body to respond to a request. It's able to change behavior based on some policy. We've had like various ideas around an OPA proxy that will allow you to receive requests and write policy around responding bodies as they were received. But OPA doesn't have a proxy mode at the moment. We integrate various proxies, Envoy and various things, Kong or something. But yeah, in terms of like manipulating the body, you would it would be generally you'd have to write a proxy to do it, but maybe use OPA or add it to your application in order to, like I've done here, like in that example I presented here, it's within the application where that kind of data filtering use cases. So yeah, there's a general purpose policy engine. You, I suppose often you do want to integrate with it, but hopefully it works well. Any other questions?
Yeah, I guess I can do it without mic. So, like, first of all, thanks for the presentation. And at the beginning, you mentioned that service meshes and their flow is TLS away from applications. But with this whole thing, so you actually offload authorization part of the application, right? But with this regular links, they're quite like cumbersome. And I just wonder how scalable this approach can be if you have a service, with dozens of different features, etc. And you have a separate of Regos that lives outside of the application. And identity part is like a cool one, but maybe it makes sense more to have some ACL, etc. I don't know if it's possible or you can share some thoughts.
Yeah, there's a few parts to the question, I suppose. Like, I suppose you're right to highlight out maybe what might appear to be a kind of inconsistency and, you shouldn't be uploading your identity. Like, I guess the way I see it is that you're only uploading some of your policy, and your application still needs to know that it is interacting with, or maybe it's some library that lots of different applications in your business that has the open integration, not necessarily implemented by everybody. So I think it would be similar if it was you can have the mesh do your authorization by tracking the OPA Envoy integration for authorization is a common implementation of doing that. So the idea of this talk was trying to get people to think about not doing that and trying to think about what it looks like from doing it within your application. As far as like the regular language and the scalability of it and so on, like this is I suppose what we do at Styra, and we encourage people to do. And I think the language may be often intimidating at first, but a lot of people do get to like it, to enjoy writing it, and I suppose that's why I ended up working at Styra and so on. But yeah, there are lots of, I suppose, different ways you could look to, not necessarily have every single engineer in your organization writing applications. You could have standard sets of policies or something which is, you know, based on paths and something high level, and allow them to dip down into Rago if they need to do something specific. Yeah, I suppose the idea for this talk is kind of like, well, can you authorize a platform service? And think about your other platform services. You probably don't necessarily have teams writing Prometheus configuration or Dev themselves. Maybe they have some abstraction on top of it. That's in platform I've worked on. That's often been the case. So you might want to do something similar to your policy, but I suppose to rather than like talking about the downsides and how to avoid them, like I think some of the benefits that you can get aren't necessarily for the platform engineers or for the application developers, but are in many ways more for like a kind of security team context, or if you're a large enough organization to have an identity team or a team working with type of it like that, then it would be particularly valuable for them for sort of auditing reasons and compliance, and checking the policy, the same policies enforced in lots of places and audited, logged and audited in a similar way. I think when it comes to sort of platform and developer teams thinking about this, it can be quite good to, or quite useful to be able to update policy out of standard deployment pipeline. You may be wanting, I think there are valid use cases for wanting to roll out new policy for the communication which is happening in the world without necessarily having to go down a potentially cumbersome deployment pipeline or a staged rollout through lots of different environments. If that's the world that you find yourself in. So I think, yeah, OPA has a little service API is a standard way that you can distribute policy bundles around. And it has other, I suppose also is like policy decisions based on data and implementing distribution of data to different applications in order to make organization decisions could be quite complicated, but OPA I suppose has some functionality there as well that you might want to lean on in order to distribute data around or standardize how that works with. So yeah, like it's pros and cons, but hopefully I'm sure I made a little bit of an attempt there to sort of explain what the value of it might be. But if you want to chat about it afterwards, talk about more detail. Yeah. Another question here in the middle.
Is there a? You can, you can
I can hear you.
Yeah.
Basically, I think you mentioned about the high integration of workload management. Why discuss
how does that work? Or
yeah.
Well, I suppose in this example, the idea would be that you would distribute trusted private CA material to different environments where you wanted workloads to be valid. I guess that's how you would federate identities in this way, and systems of federation in this space generally. Using personal certificates usually around moving or managing how CA material is distributed to different environments so that different identities are trusted. So all of the identities which are issued are what the key, X509 key usage affairs, and they are signed by some certificate authority, a private certificate authority with a particular boundary or within a particular trust boundary. The way that you would have those identities trusted elsewhere is by making choices to that CA being trusted elsewhere. You that might require some refactoring, renaming, or something, but I guess that's how I think about it. I think about federation model, controlling how it would.
I think they also leverage JWT based trust as well, right?
Yes, so there's like that's an entirely different kind of stack. Like SPIFFE does have a JWT flavor, and yeah, I've got like different feelings about JWT, I suppose. But yeah, there is systems for doing federation with that implementation, I guess, as well. Maybe a problem I have with that thing with JWTs is like the idea is so JWT is for me is subject to that. It fails on the map vector where you might be communicating over an empty channel, but somebody is misbehaving with the log, and the logs aren't stored properly or something, and all of a sudden it's effectively allows impersonation again. So I've not, and I guess it's not my background, so I'm not qualified to talk too much about JWT stuff. But yeah, there are ways to do better with that.
And what about integrity check for workloads?
So around this sort of attestation of where the sort of infrastructure backs are credential in the first place, kind of like how much do you trust, sort of where do you trust up to, or integrity of like how that credential got there.
What are the workload basically if you want the during transit or standard? So how do you those things?
Okay, so it's not about whether or not the private material that the workload has is valid, but rather about tampering on that.
Yeah.
So in theory, that's not possible with like public key cryptography. In theory, but I suppose maybe more concern would be around how you get those credentials to the workloads in the first place. That is maybe more subject to tampering with, or maybe requires a little bit more trust or something. I guess that was my kind of handbrake slide. Really, was like there are lots of different ways to get SPIFFE IDs to these things. Like there's lots of different ways to get SPIFFE IDs there. But once you have a MTLS channel or MTLS credentials to use to establish an MTLS connection, that should be pretty. We all hope. Yeah.
I guess defense in depth, if you have to, if you need to have a defense in depth, then maybe that would, having those steps would help security control.
Mm-hmm. Yeah, I suppose there are probably additional things you can do above beyond MTLS. I guess again, that's venturing into not something I have much familiarity with.
Are there any further questions? Because if not, yeah.
Quick, how do you test the policies?
How do you test the policies? So there's a test command, which allows you to write tests, and you can say forward the policy rule with this particular. You get the expected results, similar to like a test or testing framework in a language you're familiar with. In the Star product, there are various kind of more advanced things about testing live testing of policy or running two versions of policy at the same time. But yeah, unit testing or something that you would run on your laptop as the open testing.
And usually, who owns the policy?
Who owns, like in the organization?
In the organization.
Yeah, so I guess that's it's up to you really, but at a small scale, one use case it would be I don't know, if you're following a model similar to the one that I presented, it might be a platform team that own the policy, maybe developers in the organization might make requests or something, they might own it in that case. But if the policy is more around compliance or something else at a higher level, it might be owned by an identity or security team. But I suppose it's sort of the Kubernetes YAMLs kind of similar thing, like it's owned by the application developer and make changes to the deployment spec themselves, or is that abstracted away to YAML deployment? You can think about policy in a similar way. You might turn on certain policies for a certain team or a certain application, or you might have them write the policy themselves. It's up to you really how you do it.
So you can have like organization where you have some policies be defined by certain parts of the organization, and then you can have an application to define your own.
Yeah, so it is possible to plug in like different sets of policy into a single OPA instance. So you can so there's a policy bundle, and in a policy bundle you can specify OPA, so that where all the routes that policy bundle occupies, in effect, you can't have conflicting routes, but if you do make sure you don't have conflicting routes as to where those policies are mounted, like a word in the instance, then you can have multi-tenant policy in that way. So it doesn't have to be owned by one person, I suppose. It's only one. Yeah. Hopefully that's
Brilliant. Thanks so much, Charlie. Impressive to manage to get the live demo going. Yeah, that's been a lot of I haven't.
I thought that actually that would be more comfortable.
Next time, reverse accent. Yeah, thanks so much, Charlie.
Thank you, Charlie.
do the honours?
Yes, we've got some giveaways. Who? So Charlie.
Who asked the best
Who
question?
asked the best question?
Oh, goodness. I was hoping. Just overall, we've got a few things to give out. I always like to be challenged on whether Rego is any good, and that's not apparently. But it's I did have a chance to come back on that. I thought this question as well was very good about who owns policy. Like it's not a simple answer, but I thought those particular questions for me to think about. So yeah.
So which two are they? Right here. Yeah. Thank you. And the guy at the back. You got a book each.
If they like the books.
Yeah, yeah.
Now, the next stage is 5 to the
Yeah, so please.
The other questions are good as well. So we've
got some t-shirts, so all the people are, and there's loads of stickers at the back as well. There's enough for everybody.
I don't like having big papers, so maybe you can share the books or something between you all at a future.
T-shirts.
Wow.
For the questions.
Well, I guess we should people could get books.
Yeah.
Trying to find the
Yeah, we've got
fair
small, medium,
system.
large, extra large, and we don't know this in this one. So
Mystery size.
mystery size.
The OPA policy for giving out the t-shirts.
Yeah, exactly.
Yeah. So, while Jess is distributing the gifts, so just a reminder, we've got our next meetups in June, the week after. That's 21st of June. All the details will be broadcast in the next few days. But so please keep an eye on our meetup page, on our LinkedIn page, and you probably get an email as well if you subscribe to meetup. If you do have any questions or you want to speak at one of our events, please do reach out to us. The email address is really simple. It's team@dsrlg.com. We'd be more than happy to take a look at your suggested talk. And as I said, we've only got 10 minutes. That's all it takes to get your message out there. That's great. This is your community. This is your meetup. So it's your opportunity to share your ideas with your colleagues within the desk community. So this is yours. What you're doing, you can do. So, Jess, have you got anything to?
I haven't got anything to add. No, I thought it'd be good to end on a shout out for the events that we've got coming up. Thanks so much for coming down. It's really good to see you beyond the LinkedIn profile.
Finally, a big thank you again to Michael and Veracode for hosting us tonight and the lovely food. I think or some food.
Yes, plenty of food.
And Veracode, and also we're all going to the pub.
So if you turn left outside the building, cross the road, the sugar loaf. But eat the food first.
Eat the food first. So thank you everybody for coming. So thank you, Charlie.
I have a small and
I'll take the
small. Excel, and I'm not sure what
I've been the host,
If you're happy to take them through your side. All right, let's end broadcast.